Okay, so hello everyone. This is my first time at the RTC.ON conference series, so I'm really excited to be here. Thank you for your time and thanks to the organizers. I am Antonio. I am a machine learning engineer. I currently work at Miteco, and I apologize in advance, but I'm gonna use at times the P word in this talk, but I am a Python programmer for both work and leisure. Yeah, so for those of you who don't know Miteco or Mitico, there is still not an agreement on that. We are a Naples-based technology company, and we are specialized in real-time communication technologies. So among other things, we are the guys behind the Janus WebRTC server. I guess some of you might have heard of that. Okay, before we get into the nitty-gritty details of the presentation, I just want to give you like a little, context. So I joined the guys a couple years ago, and the first thing we wanted to do was to transition, our transcription service from like a third-party thing to something more controllable. So we wanted like an in-house thing that we could, interact better with. And of course, everything looked nice and fun and easy. I was like, yeah, no problem, absolutely. Just give me 20 minutes and some duct tape, and you will have your transcriber. Of course, it wasn't that straightforward. So yes, there was something of a learning curve to it. Eventually, we brought it home, but alongside that, we also brought home some lessons. So there was like something we learned from that. First of all, of course, like Python and machine learning times, like those things are really hard to mix with real-time systems. And then, of course, we started from with a transcriber, but then soon enough we realized, oh, but there is like hundreds of things we could do with that. It's like endless possibilities. So we took all these that we learned, and we decided to stick it into a library that we ended up calling Juturna. There's a funny thing. Juturna is actually, in the Greek mythology, is the wife of Janus, which is the name of the... Yeah, this is just for you to know. And she's the goddess of fountains, so we associated that with streams. I don't know if, that kind of works, but yeah, we're also open for suggestions on the name part. Anyway, long story short, so we have this library, which is a Python library that allows users to design, implement, and manipulate multimedia real-time pipelines. So there is, I think, a little need for explanation here, but essentially you can create these entities that are asynchronous and run in parallel. They can consume input streaming data that can be like multimedia data, but you can actually span them to anything you want, even like tabular, whatever. And then you can transform these data, and you can just send them to any destination you like. So, of course, there are like many tools, for this sort of trade, but yeah, there are like so many ways to skin a cat. And sometimes you might have a hard time if you do that with a spoon. So we wanted something that could actually fit our own needs. We wanted something for fast prototyping. So the idea is that, yes, you have a pipeline for like your service, but maybe you want to change model, you want to use something that works completely different, or you want to use like a different source. You want to use, to send your data to a different thing. So, we needed these, and we also needed something that was somehow self-contained. So like a single Python instance, like a single interpreter that would do like all the things that we needed. So we collected all these thoughts, and we had like some, we kept an eye on some design aspects that we wanted to respect in the library. First of all, it's all Python, of course. This kind of, makes it easier for people that come from that area to kind of like jump in and have like a platform that they can use to just, getting like some data and implement like new algorithms. Then of course we wanted something that we could also use like to measure. For example, like you receive like an audio stream, and of course you want, for each package you want to measure like the traversal time of your pipeline, so you can do that. And we also kept an eye on deployment. So with Juturna you can easily like deploy as many pipelines as you want with like a single Docker container. So that comes pretty straightforward. So this is an example of what a pipeline might look like. So in this particular example, we have like a remote source. It can be a Janus WebRTC server that is forwarding an audio stream or a video stream, but it can be anything else actually, anything that provides RTP in this case. So it can be an FFmpeg process, or it can be GStreamer, it doesn't really matter. And then we have a pipeline that branches out into like two different branches. There is like an audio one and a video one. So for the audio part, we of course read in like the audio stream, and then we pass it on to a voice detector, which essentially will flag the audio content and will signal a transcriber whenever there is a voice activity within that waveform. Then there is a transcriber that transcribes it, and a translator that translates the text that is being transcribed. And both of them, signal the output to HTTP endpoints. For the video part, we have like a video RTP source that sends the frames it receives to a motion detector system that eventually will annotate those frames with a pose estimator model. In this case, might be like a YOLO model, and then everything gets sent using FFmpeg to an output video stream to a destination point. So under the hood, like a pipeline is just like your regular JSON file. So in this case, there is like a bunch of meta info, and then there is a collection of nodes and a collection of links. So each node will, of course, it will be decorated with like its own configuration. This is an example of what like the audio RTP configuration might look like. So you want to specify the receiving host and port. You want to specify the audio rate of the source, like how do you want to buffer like the audio you receive. Same goes for the video. I mean, I guess you get the idea. So any node will have these. In this case, for example, we are specifying like the model we are using for the pose estimator. We are using like a YOLO model, and the same goes for the destinations. So once you have these, you specify your links, which is just a connection from like a source node to a destination node. And once you have your hands on these, the only thing you need to do is to load them and create your pipeline. So in order to do so, you need to install the library. So at the moment, Juturna is not published on the Python registry. So we are considering that, but you can just install it as easily from the GitHub repository. And there is like two main components to the Juturna repository. The first one is the core library. So the core library just contains all the basics you need. So like all the basic elements, such as nodes and pipelines. And then there is like a small hub, like integrated utilities for CLI and node downloading. We're going to see that in a second. And then there is a small collection of built-in nodes. So these might be source nodes for audio streams and video streams, or even multimedia files if you want to test your pipelines. And then there is a plugin folder. So this folder essentially, it does not get pulled, when you install the library, but this contains a collection of community nodes. So the idea is that if you work on a node that does something, what you can do is like you run a pull request that will be integrated there, and then other people can use that very node. Or you can just go there and browse it and see, oh, this guy did something that I need to do. I will just pull their nodes. So, okay, to have like an high-level overview of like what happens, within a Juturna process. So you have like your Python interpreter. This can be executed again, like in your local machine or your Docker container, doesn't matter. And this brings in what I just said, so built-in nodes and maybe your local nodes. So these are nodes you are developing, you are designing on your machine, you're working on them. Then you load the configuration file, and maybe you want to access to some of those community nodes. So these are like nodes on the repository. You just can download them, all the nodes that you need. Then maybe you have like some private nodes. So these are like nodes that you're working on with your company or just like by yourself, but you don't want to share them with other people. So you just download them the same way, authenticating the request. Then you assemble them and you create your pipeline. Once the pipeline is created, only thing you need to do is you manage its life cycle. So you warm it up, like you assemble all the resources it needs, you start and you stop it. So there are like a couple of points here in this slide. So the first thing is that, like, as you can see, like nodes, they are able like to get their own resources, and those are like local resources. So in the example that we saw above, like if I am running, I don't know, like a Whisper model for transcription or like any other translation model, it doesn't really matter. Those can be local to your machine. But it's just as easy, like if you're using like a third-party service to do so. So you just implement a node that would like respects, like uses like the APIs or whatever third service you have. So this is really up to you. Maybe you have an LLM model that you want to call, and instead of using like an Olama instance locally, you want to use a remote one because your machine is too old for that, or like you don't have enough VRAM or whatnot. All right, so I want to quickly show you also like some code snippets. I will go fast on these, also because like we're getting close to the lunch break, and I don't want to be in the way. But anyway, yeah, there is really no need like to fully understand. It's just like to give an overview of like the logic of like how you can use this library. And thankfully, Python is like pretty close to pseudocode. It's like dumb enough to be easily understandable by anyone. So, all right. So the first thing you do again is like you can download you can download nodes from the repository. And you can do the same if you have your own node repositories. So those will be privates. Once you have them, you just create the pipeline, you warm it up, then you can start and stop it. So like the start is non-blocking, which is not for granted in Python, but like these pipelines, they will run asynchronously. And yeah, the same things, you can do it using like a CLI. So you can download individual nodes, or you can download full pipelines. So like in this case, Juturna will just scan like a pipeline file, like a configuration file, and go through all the nodes and make them available. So when it comes to designing nodes, again, that should be like, we try to keep that like as easy as possible, because this is intended for fast prototyping. So you should be able like to design your own node in minutes. So the first thing you can do is like you can design like a stub node, and or like you do it manually. It doesn't really matter. But like this is what a node looks like. There is just like a collection of like 4 files by default. Like you have like a configuration file, and then the node class, and then you have like a README file and the requirements file, which might be seen by someone as a courtesy files, but it's a courtesy to whoever is going to use these nodes. So in the class file, which is the .py file, you can see the stub of a node. So again, like a node is just a class that extends base node. In here, you can specify the type the node expects as input, and the type the node is going to provide as output. So this gives more control over like the node interfaces. But essentially here in the constructor of the node, you have access to the configuration elements for that node. These are the ones specified in the big JSON file. So you have like some default values, but you can override them when you create your pipeline. Of course, you can manage resources for that node. So you can require system resources or allocate other static resources. It doesn't matter. You can hot swap some of these values while the pipeline is running. So maybe you are using like a particular model, and then you want to change model for any reason, maybe like for load balancing. Then you can do it, at runtime. Then, of course, like the most important piece of coding here is the update the update method. So this is the method that gets called whenever there is a message available for the node, and the node itself needs to produce a message that will be transmitted downstream in the pipe. So this is what an update might look like. So I take the data from the message I receive, I generate new data, processing them in any way, and then I transmit them. So now when I implement the update messages, just need to make sure that like the signature of the message respects whatever the node defined here. So if you look at like the class signature, I have two types of payloads that I expect, the input and the output. So in the update signature, I expect that message to contain a payload of the input type, and I expect the update method to transmit a message with a payload of the output type. So we created this mechanism to have like a more standardized way to use nodes. So whenever you want to use like a node, a node implemented by someone else, you wouldn't just get crazy and have to go through their code to understand what the node is returning. Of course, there is also the flexibility to implement your own payload types. All right. So okay. I also wanted to show like a demo. But of course, there were like some technical challenges, and for those of you that were like at the last JanusCon, I already presented like a small demo about like a transcription. So I wasn't able like to fully do it here. So the only thing that I managed to concoct is the audio part of like this pipeline that I showed you. So if you can see here on the bottom right of the screen, there is the live transcription of what I'm saying that is followed by the translation. Of course, there are many problems, and even the JanusCon, like, it didn't work as we expected, just because we are using the ambient microphone that is picking up my own voice and then the voice recorded from the room, so it's a bit messy. And also because like this is running locally on my machine, the models are distilled, quantized, tiny, so ultimately maybe not the best. This one is the distill, large of whisper. Here is the configuration that I'm using. And these are the models for the translation. So this is a model from Facebook called No Language Left Behind. It's really not optimized for Italian. So in this case, it's translating Italian. But yeah, this is the idea. And here I am simulating an RTP stream, picking up from my microphone, going into the pipeline, and the pipeline is sending the results to HTTP endpoints, which are still local, but I guess you get the idea. All right, so this is where we stand at the moment. We are supporting a number of like data sources. So we're supporting RTP audio, RTP video. We're supporting multimedia files that came super handy when we needed like to test some of our pipelines. And of course, like at the moment, we are like super easy to integrate with any Janus-based application. And similarly, we support like destination nodes, like sync nodes. We support HTTP, UDP, or WebSockets. Anyway, we are still, this is still a work in progress, like the package is available, so you can download it and use it and break it and put it back together. This is like highly encouraged. Like we would really love to see how Juturna does outside of our own like use cases, so and see whether like it generalizes and can be of any use for you. So that was me. Thank you very much for the attention. And if you have questions or comments, I'm here.
Thank you very much, Antonio. I think that now is the moment of truth who values more curiosity than food. And I think that we already know.
I do have one question. That's
Sure.
a great presentation, by the way.
Thank you.
Love the progress.
Cheers.
You mentioned that you can ingest RTP video. I was wondering if you already have some plugins that deal with video. What are you doing with it at the moment?
So at the moment, so these the pipeline that I showed is actually a two-part. Like we are using both of them. We participated in a project where we are ingesting RTP video and we are annotating it using some custom YOLO models to detect, let's say, dangerous situations in workplaces. So, for example, the one we have in place now is one where like you can look at the frame and you can understand whether there are people without safety helmet. And if you detect one, then you just send an alert. Anyway, for other like demos and things like this, you can just hit me up and.
Sounds awesome.
Thank you,
man.
Cheers.
Any other questions?
Quick one. What about concurrency? Is there, like thread-wise, is there a way to, let's say, parallelize the pipelines? You mentioned like nothing about concurrency. Just curious. It's up to Python to decide, or you have a control over it?
So these are concurrent pipelines. Like this thing is a bit tricky because, like by default, in threading in Python is kind of a joke. In the sense that, like,
that's what I'm asking. Like, is there any control over, let's say, like Unix environment? You have like POSIX threads, right? Is there a way to distribute between threads at least, or stuff like that, or it's like Python distributes it between threads? You have no idea what's going on there.
No, like by default, like for a pipeline, you ideally have like one thread per node. Okay. Now the thing is that, like, starting Python 3.13 or something, they give you the option to disable the GIL, so you actually have like real multi-threading. In our experience, though, this works still fine, even if you have like the default GIL multi-threading. This is just because some of these nodes, they perform a heavy I/O operations or like GPU or network, which is fine. Like if you go on CPU, though, like you will, this is pretty much running them serially. So yeah.
Cool. Thanks.
No problem.
Is that how you do, for example, transcription for video calls in Janus? Oh, I guess it wasn't heard, so I repeat. Is it how you handle transcription of video calls in Janus?
Yeah, so at the moment we have like a companion app working in Juturna that takes a forwarded Janus audio stream, and we annotate it with the transcriptions. We currently use it in production for the IETF meetings. So yeah.
And how it performs, because as far as I know, Janus is highly performant software, and then you throw these streams onto a single-threaded Python instance, and it's able to.
Yeah. Well, I mean, the pipeline can also reside like on a different place, right? So you can have like a different instance. Like the important thing is that you get access to the Janus forwarded stream. So you can actually have like a separate machine where you run your Juturna application. So that's what we are doing. Also because at the IETF we have like 8 parallel tracks. So we can do it with like a couple of instances, but still we need like a separate architecture for that.
Great, thanks.
Cheers.
Any other question? So I'm gonna have a question, because the part of the models that you guys are using in this project, I'm just curious, are you taking something off the shelf? Are you doing some tweaking in-house to them? How does it look like?
So at the moment, for everything that we use in production, we are taking off-the-shelf solutions, especially like Whisper. The main problem there is that Whisper is not designed to work on live data. So you would still need to have like some buffering on the data, and then you might have issues, especially when like you cut a word in between like 2 buffers. But at the moment we are fixing that with a kind of like moving buffer. So we are using off-the-shelf solutions in terms of models, but this library Juturna can also be used for like training purposes. So if you want to specialize the Whisper instance using, let's say, the IETF dictionary, that's easily done.
Okay. All right. Let's give another round of applause to Antonio.
Thank you.